Hello, welcome to the secondary PU Science students of the Papa Residential PU Science College Kalburgi. So now, in case of lecture number 1, from lecture number 1 to 3, we have studied the concept of integration with parts. In addition to theory, few examples we have solved up to 1 to 3. In case of lecture number, few examples we have left, and those examples are nothing but usually they are going to ask for 3 marks. So now, in case of integration by parts, there is a formula. This formula plays an important role, that is integration of product of two functions can be done with the help of integration by parts, where that first function is f of x, second function is g of x. First function we are going to write as it is. We are going to take the integration of second function, and now according to the formula, what it says, you have to write the integration symbol, and we have to take the derivative of first function and integration of second function. So this formula plays an important role throughout exercise number 7.6, which is relevant to the integration by parts of the chapter indefinite integral particular. Okay, so now one more thing, as previously we solved the example. In addition to solving the example where integration by parts by using that product of the function, in addition to that, I have remembered that one of the advantage or one of the new thing we all learned, that is we have calculated the integration of log x. Nowhere up till now, up to the integration by parts 7.6, nowhere we are not solved, but with the help of this chapter we are able to calculate integration of log x dx. So this is the new thing, this is the advantage, this is the important thing behind learning, studying by this integration by parts. So similarly, there is the next example, today's first example. What is the, I'm going to write the first example, so afterward we are going to discuss. See, this is the example. Integration of tan inverse x dx. So is there anywhere we have calculated integration of dx? Don't get confusion. So integration of 1 divided by 1 plus x square dx is tan inverse x plus c. So we have calculated integration of 1 divided by 1 plus x square. We have not calculated this is equal to up till now, because we don't know integration by parts chapter. That's why we are not calculated. So now one more thing, new thing that we are studying, that is nothing but we are able to calculate the derivative of this inverse trigonometry function. The derivative of inverse trigonometry function can also be calculated by this integration by parts chapter. Okay, let us look at the solution of this example. So this is the advantage. So this is how one should have, we being a human being, so one should have a curiosity. Why is it necessary to study this integration by parts chapter? What is the necessity? That type of thing should be moved in your mind, so that we can enjoy this chapter, enjoy the example solution. See, the example is integration of tan inverse x dx is your example. So inverse trigonometric function. So now, as usually, we can take at any cost tan inverse x as first function and dx as second function. So that is equal to, according to the formula, what it says, first function tan inverse x as it is, integration of dx is x, minus symbol. Next, what? First function derivative, tan inverse derivative is 1 divided by 1 plus x square, integration of dx is x, and dx, this is equal to x tan inverse x minus of, see, integration of tan inverse x is 1 divided by 1 plus of x square, and right, this much we have written. Slide here, just I'm going to write here as it is, this quantity as it is, and this quantity 1 plus of x square as it is, and this dx also as it is. So now, in case of denominator 1 plus of x square is there, In case of numerator, this I am rewriting as a numerator, that is x. So now ultimately afterwards we want to integrate this quotient from extra 2. Can I write extra 1 by 2? Why I am writing? Because to get the derivative of denominator in the numerator, 1 plus of x square derivative is 2x. That is there already in the numerator by writing extra 2 dividing and multiplying by 2. So it comes in the standard form, so that x tan inverse x is minus of 1 by 2. Can I write directly log of denominator function 1 plus of x square plus of c. So therefore, the answer we can conclude that in integration of tan inverse x dx is equal to x tan inverse x minus of 1 by 2 log of 1 plus of x square plus of c will be the finalized answer. So this is how this is the important thing, that we can integrate the inverse trigonometric function with the help of this integration by parts formula, integration of f of x into g of x. So just I am going to review this first example solution. We are moving towards the second example of today. So the second example is second example. So the second example is the next one, more important. Slightly different type of example we are solving. Find or evaluate x sine inverse x dl. So here x variable is in product with the inverse trigonometry function sine. So here at any cost we have to make use integration with parts formula. That is the important thing. Now solution, the example is x sine inverse x dx, this is equal to, okay. So now here once again we can write the first quantity and second quantity, that is important. First function, instead of directly considering the first function and second function, instead of considering first and second, just after writing this step you may consider. So here we can remodify that, put that x is equal to sine theta, so that theta is equal to sine inverse x, right? And next, with the help of x is equal to sine theta, dx is equal to cos theta d theta, because sine theta derivative is cos theta and d theta, okay. See, this whole quantity it becomes, sometimes this is equal to, so they are going to call it as I, or I is equal to this equal to I. So this integral I, it becomes, how it becomes, so x is equal to, we have considered sine theta, we have considered sine inverse x is equal to theta, and next what, dx is equal to cos theta d theta. In this way, substitute x value, substitute to sine inverse x value, substitute dx value, okay. So now this is equal to, this is nothing but, can I write properly? See here, sine theta cos theta d theta, and with, in addition to this, theta as it is. So here 1, 2, 3, 3 to 4 terms are in product. So alteration I am going to write here itself. Here I am writing 2 and here I am writing 1 by 2. No, nothing will not happen by dividing multiplying by sine number. Why I am writing? Because 1 by 2 times of theta times of sine 2 theta d theta. So next you are going to consider first function as sine theta and second function as sine 2 theta according to the integration by parts. See here, According to that, this is equal to what? 1 by 2 is the common factor to all the first function sine theta, as it is integration of sine 2 theta is minus cos 2 theta divided by minus cos 2 theta divided by 2. And next minus symbol, integration symbol, what? Differentiation of first function. Differentiation of theta with respect to theta is 1, may write or may not write. And once again integration of the second function minus cos 2 theta divided by 2 d theta. Yes, now can I close this bracket like this? So this is equal to 1 by 2 times of minus theta cos 2 theta divided by 2. Yes, minus of minus plus of